All right, so last lesson we talked about properties of equality like addition, subtraction, multiplication, division. We talked about the symmetric, reflexive, and transitive property. Those properties are going to come into play here today when we talk about what's known as algebraic proofs. Algebraic proofs basically boil down to solving an equation and just keeping track of what steps you work through to get from start to finish. So for instance, an example of an algebraic proof would look something like this. So an equation is solved below. We're going to use the properties of equality to justify each step. So in a proof, one of the things that we're going to talk a lot more about and we're going to kind of mention over and over again is that they have to start you with some information. They have to give you something off the bat. So for step number one, they're going to give us the equation. So that first step is just going to be given. Like that's what we start with. Now we're going to work from there. Now from there, we just look at, okay, from step to step, what did we do to solve this equation? So to get from step 1 to step 2 here, we look at what changed. We had 4x minus 5 equals 25, and now we have 4x equals 30. So what happened was they added 5 to both sides of the equation. So when they added the 5 over, it became 4x on its own and 30, so they used the addition property. When we go from step 2 to step 3 here, we look at what changed. We had 4x equals 30, now we have x equals 75 or 7.5. So basically all they did was get x by itself by dividing by 4. So they divided both sides by 4, x equals 75 or 7.5. There's our division property. And as far as algebraic proofs go, that's really all it is. You start with the equation and you just work through and solve it, each step keeping track of what you did. So if we look at another example here, one that's a little bit longer, so a couple more steps. We have 3x plus 24 equals 5x plus 8. And we know from the last example, we know that because it's given to us. We always have to start with that equation. Now from here, you can solve equations lots of different ways. So if you were solving this equation, you might do it a little bit differently than what you see here, and that's fine, as long as you justify each step as you progress through your solving process. So in this case, since they already worked it out for us, we have to follow along with what they did. So the first thing we notice is from step 1 to step 2 here, we had the 3x plus 24 equals 5x plus 8, and then they subtracted 3x from both sides. So that canceled out the 3x here, and then 5x minus 3x is 2x. So they used the subtraction property. And remember, with subtraction, make sure you put that t in there or else you will lose points because I won't know subtraction or substitution. So they use subtraction, and then we look at the next step. Step 2 to step 3. Well, if we look at what they had, 24 is equal to 2x plus 8, and now we have 16 equals 2x. So what that tells me is they went ahead and subtracted 8 from both sides. So 24 minus 8 became 16. The 8's over here cancel. So they used subtraction again. And when you're working through proofs, there might be times where you use the same process multiple times in a row. So it's okay to use subtraction followed by subtraction, or division followed by division, or whatever it might be. So it's okay to use the same thing multiple times. So now we're at step 3. So here's where we're at right now. When we go to step 4, we look at what changed. We had 16 equals 2x, and now we have 8 equals x. So that tells me that they divided both sides by 2 to cancel the 2's out, and now we have 8 equals x. There's our division property. And then at the end here, anytime we solve an equation, so with these algebraic proofs, we always want it to say x equals some number. So we always want x on the left side of the equation. So right now, we have 8 equals x. We are able to go to this 5th step and flip-flop. So if we think back to what we talked about in the previous lesson, when we flip-flop a statement, that was known as the symmetric property. So when we take an equation and just flip it around, so 8 equals x becomes x equals 8, we're using that symmetric property of equality. And so again, as far as the process goes, we just solve the equation on the left. We're just keeping track of what we did on the right. Another quick example here. So this one, we start off with the given. So they gave us the equation. We look at what happened for step 2. So for step 2, they went ahead and distributed the 3 times x and 3 times 8. So there's our distributive property. And then from step 2 to step 3, it looks like they subtracted x from both sides. So that's where the 2x plus 24 equals negative 14 comes in. So they subtracted. And then to get 2x plus 24 equals negative 14, to change that into 2x equals negative 38, they subtract 24 from both sides. So we use subtraction again. And then to get to x equals 19, they went ahead and divided both sides by 2. So for step 5, they used division. And so again, you're just keeping track of what step, or at each step, what process did they use. They distributed, subtracted, divided. So just keep track of the steps, and that's all you're doing. If they ask you to solve an equation or they ask you to write an algebraic proof, it's the same thing, but now you're the one doing the solving, which means you get to determine how to solve. So your proof might look different than someone else's proof depending on how you solve, and that's okay as long as you keep track of exactly what you did throughout the whole process. So here we start off with what they gave us. So we just start off with the actual equation. So step 1, we write down what they gave us. Step 2 then, you have to decide how you want to attack this problem. So most of you, when you see the parentheses here, are conditioned to distribute anything into the parentheses. So I can take 5 times 3x and get 15x. I can take 5 times negative 20 and get minus 100. And that'll equal negative 10. So on that step, I distributed. Okay. Once I've done that, I look at my next step. So for the next step I would do is move the 100 over to the other side. So I'm going to add 100 to both sides, which means 15x will equal 90. And I used my addition property for that. Once I have 15x equals 90, I can go ahead and divide both sides by 15. And when I do that, x would equal 6. And that was my division property. Okay. So that was one way that we could do that problem. Now, I could do it a different way. So I'm going to choose a different color here. I'll go with blue. Now, I worked this problem out this way: distributed, added, divided. But if I had wanted to, instead of distributing right away, so getting rid of that distribution right away, I could have divided both sides by 5. So this blue is an alternate method. It's not the one you have to have, but the first thing I could have done is divide. And when I do that, that would give me 3x minus 20 is equal to negative 2. And then my next step would be to add 20 to both sides. So I would get 3x is equal to 18. And that's my addition property again. And then I could divide both sides by 3. X would equal 6 by division. So when you're solving equations, you can do so multiple ways in certain cases. And so all you have to do is just solve it the way you need to, or solve it the way you want to, and keep track of what you did at each step. So I started with the given, I worked to distribution, addition, division. Or I started with the given, I divided, then added, then divided. So there's multiple ways to do certain equations. You just have to kind of solve them and keep track of what you're doing, and that's what all the algebraic proofs are going to look like. So at this point, you should be able to complete the worksheet for today. You can either get it in class, or you can print it off a Google Classroom, or you can pull it up on a phone and copy it on another sheet of paper, whatever you want to do there. As you're working, if you have questions, feel free to ask in class, feel free to email, whatever you need to do. Check the answer key, make sure everything looks good before you're ready to turn this in.